My name is Robert Shannon, and for this project, I am doing a loan risk analysis. And before we sort of get into what that's going to look like, let me give you a little about myself. I grew up in Bend, Oregon. I graduated from the University of New Hampshire this last spring of 2020. And while there, I got the incredible opportunity to compete as a Division I athlete and complete a degree in economics. With the use of an economic background and the knowledge gained here at the Galvanize program, I wanted to apply the two to a loan risk analysis. A quick background on loans is that the U.S. Department of Education reported that 20% of borrowers are actually currently in default, and that's defined as having gone at least 270 days without payment. More than 1 million loans go into default each year, and the world's banks are set to write off $2.1 trillion over the next 2 years as customers are expected to default on loans because of the COVID-19 pandemic. So getting into the goal of this project, I wanted to create a tool that can be used by bankers that allows for better understanding of the customer and the risk involved to in turn maximize their profit. This tool is to be used specifically as a source for better understanding the potential profit from a customer rather than an outright definitive answer to who or who shouldn't receive a loan. So taking a look at my data, this data is hosted by thelendingclub.com and it was collected between 2007 and 2010. It contains roughly 9,700 bank accounts, each with 13 non-identifying attributes and a result, depending on whether or not they paid back their loan. So on the right here, we're looking at which purpose the loan was used for and which one was most likely to default. You can see that small businesses came in at roughly 55%, which means that meaning almost half of those loans given to small businesses actually happened to default, while education and home improvement wrapped at our top three. Before getting into applying a model, I looked at the features in my data to verify that the data was what I expected to see. For example, I looked at the FICO score, and as we would expect, customers who defaulted had a lower FICO score, and customers who didn't default had a higher FICO score. We can see on the graph here that defaulted customers tended to have a FICO score below 700, while customers who fully paid off their loans had a FICO score above 700. With the reassurance from exploring my data, I was ready to start modeling. So in order to predict which future loans had a higher chance of defaulting, I applied multiple machine learning models to my data. So my focus for the model itself was the precision score, as I didn't want to predict a loan going into default, even though it didn't, which would result in a loss of profit. The other consideration when choosing a model was the ability of the model to maximize profit. Out of the applied models, my gradient boosted model performed the best and is what I use in order to determine the future profit. So in order to assign a monetary value to the model, I had to make some assumptions on loans. The first assumption was that if a customer fully pays off their loan, then the company can expect a $2,000 increase in profit. And on the flip side, if a customer defaults on their loan, then the banker can expect to see an $8,000 profit loss from that transaction. So with those assumptions, I'm able to calculate a profit curve. The first thing to look at here is the far left of this graph. If the banker denies every new customer loan, meaning they get no profit, $0, or if they deny everybody, they get $0, no profit. So then now looking at the bottom right, if the banker gives every single person a loan that comes their way, then the profit is in the negative. Now, if my model is applied with a loan acceptance rate of roughly 17%, then the banker can expect a roughly $400,000 profit. Here, I wanted to highlight exactly what was going into my model. Outlined on the right is the top 5 attributes of the bank accounts that had the highest influence. Inquiries in the last 6 months came in first, and that kind of outlines how many times a customer inquired about a loan from a banker in the last 6 months. While we can see that interest rates and installment finished out our top 3. So for my conclusion, if my model is applied, the banker can expect an increase of roughly $132,000 per year. For my recommendations, I recommend that if the new customer happens to be a small business, then check that the inquiries are less than 3 and that the FICO score is greater than 700. And if the new customer is using a loan for education, check that the FICO score is greater than 700. And with these recommendations, a large decrease in the amount of a large decrease in the amount of defaulted loans can be observed. There's my contact and the tech stack used for this project. And now is a great time for any questions. Thanks.